So have you all found what is V1 and V2? Now let's check. So V1, here do you understand? In this circuit, the same current will be flowing through all the resistors. Here, although we have earth, the current won't go. Current from the battery won't choose this way, okay? Sometimes you might have that doubt. The current will go to earth. It is not true. What will happen is, whatever current that leaves the battery have to enter the battery. If it is I, then this also has to be I. Okay, therefore this will be the path. If you had a confusion, okay, if you had any doubt about the path, this is the path. So, can I straight away use the potential divider equation? Yes, because it is the same current flow throughout. Therefore, we have V1 is equal, that is 50 over, what is the total potential? Sorry, total resistance, 100, right? Into 10. Therefore, V1 is equal 5 volts. Okay, then V2. V2 is equal, if you find, it will be 2 volts. Now, there's a small problem. The problem is we are measuring the voltage. We are measuring the voltage with a voltmeter. This voltmeter has terminals, positive terminal and negative terminal. So how this voltmeter is going to read is, it will always, so just look at the question, okay? In questions, sometimes they might have given you plus on one side, or plus and minus. So in this case, let's say this is V1 and this is V2, then the reading V is equal V1 minus V2. Okay, this will be the reading. So now let's look here. What is minus? What is V minus? V minus is 0. And positive is connected to positive. Therefore, V1 will be plus 5. Now let's go to V2. In V2, negative is connected to 0. But the positive is connected to even lesser voltage. When current is flowing in this direction, when the current is flowing down, it will always move from higher to lower potential. So the potential of B is less than 0. So it will be negative 2. Is it clear? The potential of B will be negative 2. So the reading of the voltmeter also is going to be negative 2. Is everyone clear with that? Or shall I explain once? Tahama, do you get the idea? So here, note this one also, then it will be easy. Maybe you can note this one too. Let's say we have a resistor and this is the direction of current flow. This is V1 and V2. V1 is greater than V2. Okay. If V1 is equal to 0, if V1 is equal to 0, that means V2 will be less than 0. Okay. So it's not a problem. Potentials can be negative. Is everyone clear? So when you are answering MCQs, you must be very careful when you get this voltmeter. You must think about the direction of current and identify whether the voltage will be negative or positive. Okay. I'll make a small change for this question. Then what will be the answer? Here, this point is connected to earth. This is grounded. And this is point B. Same question, okay? This is 20 ohm. But this time, the voltmeter is connected like this. The voltmeter is connected like this. Now what can you tell about the reading? Is it 2 volts or negative 2 volts? Is it 2 volts or negative 2 volts? Okay, let's see. What is the potential here? What is the potential over here? It is 0. What is the potential here? It is -2. Now, what will be the reading? What is the reading? What is the reading? V is equal V plus minus V minus. So V plus is 0 minus -2. Therefore, it's 2 volts. So the idea is when you have a voltmeter, what you have to do is you have to deduct the potential on the positive side from the negative side. That is the idea. So here, what is the case? The positive side is connected to -2, negative side is connected to 0. So when you get the difference, it's -2. But here it's different, okay? So you can note this one also. If so, did you get the difference between the previous question and this example? 3 of you? Saja and Shahama? Okay, so shall we move on to the next question? Question number 21. Pick your answer. Okay, right? Others, Sarah and Saja. The same question, but slightly different, right? Only the diagram is different, but same idea. Try 22. Saja, did you get the answer? Okay, try 22. When we have an ideal voltmeter, current doesn't pass through a ideal voltmeter, okay? No current flow. That is important. So what will be the potential here? What is the potential over here? What is V plus? Found that. What is V plus? Okay, I will got this answer. Third answer. Okay, here this is an ideal voltmeter. The current through an ideal voltmeter is zero. Therefore, there is no current going through this. Now, can I apply the potential divider equation between these two resistors? Yes, the reason is you have the same current flow through these two resistors because the current through this is zero. Is that clear? Using that, I found V plus is equal to 2.5. Got it? Now, we have a variable resistor R. When R is very much high, here they say 10,000, right? When R is very much high, so it goes from 0 to 10,000. Okay, it won't be third answer. Let's see. It goes from 0 to 10,000. When R is 0, let's say this is 0. That means you don't have a resistor. You have just a normal wire. When you have a wire, this one becomes short circuit. There is no need for the current to pass through this resistor. It will just straight away go through this. Then, what is the potential? The potential over here and the potential over here is same. So it is 0. So V minus is 0. Is it clear? So reading V is 2.5 minus 0. 2.5. Okay, Saja. How about other Sarah and Shahama? And now let's look what will be the case when R is equal to 10,000. When R is equal to 10,000, this resistance is very high. Because this resistance is very high, the current doesn't want to go through this path too. Instead, when compared to 10,000, when compared to 10,000, this 100 is very small. Therefore, the current will choose this path. There will be a small current through this, but let's omit that current. Let's say it is negligible and just forget about that. So what I did next was I have omitted, okay, I have neglected the current. Then my idea, there is no current flow, that means no resistance. There is no resistor at all. Now, 1:1 ratio, that means half. Then 5 volts. Okay, V minus is 5. So 2.5 minus 5 minus 2.5. Okay. Clear. So the current, the reading goes from 2.5 to minus 2.5. Sarah, Shahama, and Saja, clear? Try the next. Question number 32. 532. We have done a similar question. From here on, you must be able to do it by yourself. Got this answer? How about Sarah and Shahana? Okay, you don't need to bother about the potential. You can straight away use the potential divider, right? Because you have the same current going through all these resistors. Okay, that is how I have used. Sarah, how about you? Right, 33. This answer. Okay, have I got this answer? Yeah. How about Sarah and Saja? Sorry, Saja and Shaham. No, okay, I'll tell. Just look. Now this is actually we are going in reverse. All this time we were given the resistance and we were finding the output voltage, right? This time we have to find the equivalent resistance. So same idea. What I did was, if I somehow, can you remember how we found this 5 volts? What we did was, let's say this is given as 12 volts. Let's assume, okay, this voltage is given. Then what will you do to find this output voltage? First, you will find the equivalent. Once you have found the equivalent, next you will find the potential difference across that. Okay. Now what I'm going to do is, I am going to come in reverse. Because this is 5 volts, the equivalent, across the equivalent also, it should be 5 volts. Is it clear, Shahama? If it is 5 volts here, because these two are in parallel, across the equivalent also it will be 5 volts. But here I can apply the potential divider equation. So what is the potential divider equation? 5 into R dash over R dash plus 60 into 30. Now find R dash. Okay, R dash is equivalent. Now we have found the equivalent. What is the equivalent of two parallel resistors? Product over sum. So 48R over 48 plus R, that is equal to 12. Now just solve for R. You will get 16. Okay, Shahama, got it? Okay, clear. Try the next. Try 38 and 40. Again, we get V by 5 for this answer. Yeah, right? How about others? This one. Here, they ask the maximum voltage across XY, right? So we know that V is proportional to R. In a potential divider, V is proportional to R. For maximum resistance only, we will get the maximum potential difference. So if Vx was 0, this, the resistance was 0, then voltage will be 0. For maximum voltage, we need the maximum resistance R. So that is how I got R here. That's why I have mentioned Vx maximum for R of variable resistor. Okay, Sarah.